Good morning. Today we will be reviewing Chapter 1 for our test on Monday. Our first problem is asking us to select a number that's going to go in this blank square that's going to make a true comparison. And we're going to mark all the answers that apply. So first of all, I'm going to look at what I'm comparing. So we're saying that this number is going to be bigger than whatever's in this box. And I know that because remember the alligator? You draw the little teeth. The alligator always eats. I didn't do that very good. The alligator always wants to eat the bigger number. So this number right here is going to be a smaller number. So we're looking for the smaller number. So we're going to look at our place values. So first we're going to look, the 7 is the same here. Let me do my pointer finger. The 7's the same. The 0 is the same. And then this one is a 2 and that one is a 3. So yes, 2 is smaller than 3. So A is going to be one of my answers. The next one, 7. So we've got our 7s, our 0s are the same, our 3s are the same, and then the next number, I have a 2 here and a 0 here. 0 is smaller than 2, so B is also going to fit in that. It could also work on this side of the equation. So now I have a 7, and I have a 7. Then I have a 0 and a 0, so that's the same. I have a 3 and a 3, so that's the same in the thousands. In the hundreds, I have a 2 and a 2, so that's the same. In the tens, I have a 0 and a 0, so that's the same. And then in the ones, I have a 9 and a 9. So this number right here is not actually less than. This number would have been equal to. So this one is not going to be an answer. So the next problem I have is 7. So again, it's 7. 0 in the 10,000s, 3 in the thousands. They both have 2 in the hundreds. This one has a 9 in the tens, and that one has a 0 in the tens. So 0 is less than this. So this one is not going to work because this one would have been greater. And so that won't work. Or actually it would have been the other way around, I guess. It would have been like that. Keep it consistent. Okay, so let's look at the next one. So we have a 7 in the 100,000s, and then we have a 3 in the 10,000s, and 3 is definitely bigger. So this number would have been bigger. So that one does not work. And then finally, last but not least, we have a 7 in the 100,000s for both of them. But in this one, we have a 0 in the 10,000s and a 3. And this one is going to be bigger. So this one is not going to work. So my answers are going to be A and B. Okay, looking at number 2. It says Nancy wrote the greatest number that can be made using each of these digits exactly once. Well, that's pretty easy. You're just going to put the big digits. There's 1, 2, 3, 4, 5, 6, right? So in the 100,000s place, you're going to want to put the biggest number, and the biggest number in here is going to be this 9. So we're going to take the 9, and we're going to put that in the 100,000s place. Then the next biggest number is going to be the 8, so we're going to put that in the 10,000s place. The next biggest number is going to be the 5, so we're going to put that in the thousands place. And the next biggest number is going to be the 4, so we'll put that in the hundreds. The next biggest number is the 3, so we're going to put that in the tens. And the last number is going to be 1. So this is making the greatest number. Now, just in case the test has this on it, I want to go back. So if that is my greatest number, this is the answer. This is the answer. What would be my least number? I would do the opposite, right? So I would start with the 1. Then I would do the 3, then I would do the 4, comma, then I would do the 5, then the 8, and then the 9. And that would only be if they were asking me for the least, right? But they're not. They're asking me for the greatest. So that is the answer. I just wanted to specify that because they could ask the opposite in your actual test. So part A asks, well, what's Nancy's number, and how do you know it's the greatest possible number for these digits? All right, this is kind of a sloppy answer, but we did already, in fact, do the problem. So it was 985,431. And the way I know that this is the correct way is because I used the place value. I took the greatest number and I put it in the largest place value, which in this case was 100,000s. And then I put the next largest number into the next largest place value, and the next, and the next, and the next, and so on. Okay? And it's funny that they asked me this because remember, we already did it. But it says, what is the least number that you could possibly make using each digit once, and explain the value of the 4 if it's greater than the value of the 5. So remember, it's 134,000 589. And then it asks to explain why the value of the 4 is greater than the value of the 5. Well, that's because the 4 is in the thousands place value, and the value of the 5 is only in the hundreds place value. So the 5 is only worth 500, and the 4 is worth 4,000. And that's why it's, even though 4 is normally smaller than 5, in the where they put it in the place value, this 4 is worth 4,000, and the 5 is worth 500. Okay, so in the next one, we're going to be using this mountain charts peak here, the U.S. mountain peaks. And so number 3 asks to write the name of each mountain peak in the box that describes its height in feet. So we're looking between 14,000 feet and 14,300 feet. So 14,000 and 14,300. Well, this one is 14,345, so that's too high. This one's 14,294. So yes, this one is right in between. And then 14,064, this one is also in between. 14,494, that's more than 14,300. 14,470, that is also more than 14,300. And then 14,246, that is right in between. So I'm going to be writing these 3 mountains in that blank. So that's Crescent Peak, Humboldt Peak, and White Mountain Peak. So these right here fit that category. Okay, I'm going to erase those red marks so that, or actually I'll just do a different color. So now they want us to do between 14,301 feet and 14,500 feet. So this is going to be higher than this. So these ones right here, the ones in red, are not going to be in. So 14,345 is in between. 14,494 is in between, and 14,470 is in between. And I know that because I can just look at the place value, right, as I'm doing it. All right, let's put those in. So the answer is going to be Blanca Peak, Mount Whitney Peak, and University Peak. The next question asked me to circle the name of the tallest peak and explain how I know which one is the tallest peak. And do that in yellow. So the tallest peak, if I line them all up by place value, well, first of all, we know it's going to have to be one of these 3 because these are, this goes much higher than this one. So it's going to have to be one of these 3. And as I'm looking at them, if I look at the place value, I have 1, 1, and 1, so that's the same. 4, 4, and 4, that's the same. 4, 4, 3, and 2. Or whoops, I'm sorry, 3. So it's not going to be this one because that one has a 3 and these two both have 4. So it's going to be between these two. So in the tens place, this one has a 9 and this one has a 7. 9 is bigger than 7, so it's going to be Mount Whitney. So Mount Whitney is going to be my tallest peak. So Mount Whitney is definitely going to be the tallest, and I know that because I compared the place value positions. Number 5. Mr. Rodriguez bought 420 pencils for school. If there are 10 pencils in a box, how many boxes did he buy? Well, if he's got 420 pencils, and in each box there's 10 pencils, then I'm going to divide that, right? Because if there's 10 boxes in a pencil and I divide that, then I'm going to know how many boxes there were. So I can't put 10 into 4, but I can put 10 into 42. And 10 times 4 is 40, so it's going to be a 4 up here. 10 times 4 is 40. Then I subtract. Remember, I take my 2 away from 0. I get 2. And then I'm going to bring down my 0. And then 10 goes into 20 2 times. 2 times 10 is 20. So I subtract and I get 0. So the answer should be 42 boxes. Now that might be the algorithm that we all know. You might make a picture, which could be easier for you. Maybe you take the you draw 10, 10, 10, and you just keep going until you you draw 10 boxes of 42. I mean, that could work too. So you'd have 42 boxes of 10. So you'd have literally 10 of, very, very long way of doing it. or you can use the algorithm, which is pretty simple. All right, Bobby and Cheryl each rounded 745,829 to the nearest 10,000. Bobby wrote 750,000 and Cheryl wrote 740,000. Who's correct? And explain the error that was made. Well, first of all, you got to know where my 10,000s place is. So I'm actually going to go big here. 7, 4, 5, 8, 2, 9. So this is my 10,000s place. So that's what I'm looking to round to. Remember that the number that's going to tell me is the next door neighbor. And if my next door neighbor is 5 or greater, then it is going to have enough power to change the 4 to a 5. Since it's at a 5, it does have enough power to change this. So I'm going to have 7, 5, 0, 0, 0, 0. So Bobby was correct. So Cheryl should have increased the 10,000s place by 1 like Bobby did, because the 5 was what gave it the power, and 5 is greater. It's 5 or higher, so that had enough power to change the 10,000s place from 4 to 5 and not leave it as a 4. The total season attendance for college teams' home games, rounded to the nearest 10,000, was 270,000. For numbers 7A through 7D, select yes or no to tell whether the number could be the exact attendance. So remember that we're looking at the 10,000s place. I'm going to put it over here. 270,000. So if this is the number we were changing, we were looking to see if that number had enough power, right? So 265, so the 5, does it have enough power to change the 6 to a 7? Yes, it does. So now I'm looking over here. Does the 0 have enough power to change the 6 to a 7?
Maybe.
No, it does not. On this one, does the 4 have enough power to change the 7? Oh, actually, this would have been the 7 to an 8. Since it doesn't, then this does work, because the 7 would just stay a 7 because the 4 does not have enough power. So this could be the answer. On this one, again, I look at the 6. Does it have enough power? Well, first of all, this isn't even a set close. It's a 0. So automatically, that is definitely a no. Okay, so this table shows the population of, well, it's representative of data for Sacramento, California. And it's in here, I can look at the title. It says population of Sacramento, California, age in years. So under 5, the population is 35,010. From 5 to 9 years old, it's 31,406. From age 10 to 14, 30,000. From age 15 to 19, this, you can kind of see this is 20 to 34 years old. That's how many people there are. 35 to 49 years old, that's how many people there are. 65 and older, and so on. So we're going to use this chart to help us answer these questions. So it says, how many children are 10 years and older? Show your work. Or 10 years old. Or under 10 years old. Show your work. Miss Noel can read. I really can. So under 5, we know that they're under 10, right? And from 5 to 9, they're also under 10. So in order to find out the total number, I'm going to need to add these two numbers up. So let's go ahead and do a little workspace over here. So I need the 35,010, and then I need the 31,406. And I cannot stress enough for you to line your numbers up, line your place values up. So 6 plus 0 is 6, 1 plus 0 is 1, 4 plus 0 is 4, 5 plus 1 is 6, and 3 plus 3 is 6. This is kind of showing my work, so I just couldn't fit it in the box. So the answer is 66,416 children are under the age of 10. Okay, the next problem asks, how many people are between the ages 20 and 49? Show your work. So this is going to be problematic. I'm going to have to move this down again, so hold on. So between 20 and 49. So these are 20 to 34, and these are 35 to 49. So this is going to give me 20 to 49. So I'm going to need this population plus this population. So it's going to be, so my work would be 115,279 plus 92,630. Remember what I said about lining up your place values. 9 plus 0 is 9. 7 plus 3 is 10. Carry my 1. 6 plus 2 is 8. Plus 1 is 9. 5 plus 2 is 7. 9 plus 1 is 10. Carry my 1. Or regroup my 1. And then I have 1 plus 1, which is 2. So the answer is 207,909 people are between the ages of 20 and 29. Okay, now this looks weird. I had to erase the answer so that I could hop up to the next one. It'll be harder to see. How many more children are under the age of 5 than between the ages of 10 and 14? Show your work. So under 5, I have 35,000. I'm going to put it over here. 35,010. And then the answer, it asks me, and between the ages of 10 and 14. Well, between 10 and 14, so this is under 5. And then between 10 to 14, we have 30,253. And I want to know the difference because that's what it's asking me. It's saying how many more children. How many more is usually telling me that I'm going to need to subtract. So I'm going to subtract these numbers. Let me put them over here so they're easier to read. All right. And remember to line up your place value when you're doing this. Very important. So I'm subtracting. I can't take 0 from 3, so I'm going to have to regroup. I'm going to take 10 from the tens place and put it over here. I'm going to take one of my 10s, which is going to leave me no 10 there. So I have 10 from 3, which is 7. I can't take 0 tens from 5 tens, so I'm going to have to regroup. There are no hundreds to take, so I'm actually going to have to take 1,000, making this be 4, and I'm going to add that over here, which, again, I'm taking it. So there was 10, so now it's going to be 9, right? And this is going to be 10. So 10 from 10 minus 5 is 5. 9 minus 2 is 7. 4 minus 0 is 4, and 3 minus 3 is 0. So the answer is going to be there is 4,757 more children between the under 5 than there is 10 to 14-year-olds. All right, for numbers 11a through 11d, we're going to select true or false for each sentence. So let's look at the sentence. The value of the 7 in 375,092 is 7,000. So let's look. The 7, it's in the 10,000s place. So the value should be 70,000, not 7,000. So that is false. The value of the 5 in 427,593 is 500. So let's look. The value of 5 is in the hundreds place, so the value is 500. So that is true. The value of the 2 in 749,021 is 200. Well, the 2 is in the tens place, so the value is actually 20, not 200. So that is false. The value of the 4 in 842,063, the value of the 4 is in the 10,000s place, so it is worth 40,000. So that is true. All right, select another way to show 403,871, and we're going to mark all that apply. So 403,801. Well, that's saying 403,801. So that is not this number because we'd need 871. So 403,071. Well, that one forgot the 800 part of the 71, so that one does not work. This next one says 403,871. Yes, that does look like my answer. It's 1. And then this is trying to do expanded form. So this is saying 400,000 plus 38,000 plus 800 plus 70 plus 1. So that's not right, right? So let's do the next one. The next one is our expanded form, and it's saying 400,000, 3,000, there's a 3 in the thousands place. This is saying there's an 8 in the hundreds place, a 7 in the tens place, and a 1 in the ones place. 403,871, 403,871. That is correct. Now this last one is saying 400,000 plus 3,000 plus 800 plus 7 tens plus 1 1. So that is correct. So my three numbers are going to be C, E, and F. So Lexi, Susie, and Rael are playing online word game. Rael scores 100,034 points. Lexi scores 9,348 fewer points than Rael. And Susie scores 9,749 points more than Lexi. What is Susie's score, and show your work? All right, so on these problems, you really just have to lay out what you know, okay? So first of all, we know that Rael scores this many points. So Rael, her score was 1,034 points. We know Lexi scores 9,348 fewer points than Rael and Susie. Than Rael. So Lexi scores minus, she scores fewer. She scores 9,348 points less than Rael. So if that's Rael's score, then Lexi's score is going to be this minus that, right? Then it says Susie scores 9,749 points more than Lexi. Okay, well, first of all, let's find out how much Lexi scored. So 100,034 minus, make sure you line up your place values. Super important. I know I keep saying that, but it really is important. All right, so let's find out how much Lexi scored. So that's Rael's. So I can't take 4 from 8, so I'm going to have to go next door, and I'm going to have to take a 10. I'm going to add it over here. So I have 14 minus 8, which is 6. And then I can't take 2 from 4, so I have to go next door. But there's nothing to take there. Got to go next door. Keep going, keep going. So now I'm going to have 0 100,000s, and because I borrowed next door on all these, so this is going to be a 12. Because essentially, I mean, really I'm taking a 10, but then I'm borrowing it. A 10, but I'm borrowing it. 10, and I'm borrowing it. So that's why these are 9s, because I had to go all the way to the 100,000s place. So 12 minus 4 is 8, and 9 minus 3 is 6. 9 minus 9 is 0, and 9 minus nothing is 9, and then I have my 0. So Lexi's score was 90,686, so that's her score. Now it says that Susie scores 9,749 points more than Lexi. And if that's Lexi's score, then I'm going to add Susie's extra points to Lexi's score to get her score. So 90,686 plus the extra because she scored more. Make sure you line them up. I almost didn't line that one up. That would have messed me up. So I have 9 plus 6, which is 15. 8 plus 4 is 12. Plus 1 is 13. Then I have 6 plus 1 is 7. Plus 7 is 14. Put my 1 up there. 9 plus 1 is 10. Carry my 1. 9 plus 1 is 10. So Susie, which was what I needed to, that was my ultimate answer because it says, what is Susie's score? Susie's score is this one right here, 100,435. All right. Now, let's do the next problem. It says, there were 13,501 visitors to a museum in June. What is the rounded number to the nearest 10,000? And explain how I rounded. So I'm going to write it here, 13,501. I'm trying to get to the nearest 10,000. So my 10,000s place is the 1, right? Because we've got our hundreds, we've got our tens. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. So I'm looking next door to see if it has enough power to change this 1 to a 2, and it is a 3. 3 is not bigger than 5, so it does not have enough power. So that the closest number, or the number rounded to the nearest 10,000s is going to be 10,000. All right, stick with me. I know this is a long video, but we are getting there. We're about 5 away from finishing. All right, New Mexico has an area of 121,298 square miles. California has an area of 155,779 square miles. How much greater is the area in square miles of California than the area of New Mexico? Show your work and explain how you know the answer is reasonable. Well, if I'm trying to find out how much greater one number is than another number, then I know I'm not adding them together. I'm finding the difference, which means I'm going to be subtracting. So let's set up our subtraction problem. And I'm always going to put my biggest number on top. So 155,779. Make sure you line up your decimals. I mean, not your decimals, but your, well, eventually you'll do that. But we're going to line up our place values so that we're making sure that we're subtracting our tens from our tens, our hundreds from our hundreds, and so on. So I have 9 minus 8, which is 1. I cannot minus 7 minus 9 because 7 is too small of a number. So I'm going to have to go next door and I'm going to have to regroup. I'm going to take one of my hundreds, leaving 6 here, and I'm going to add my 100 to here. So I have 17 minus 9, which is 8. And then I have 6 minus 2 in my hundreds place, and that is going to be 4. I have 5 minus 1 in my thousands place, so that's going to be 4. 5 minus 2 in my 10,000s place, and that's going to be 3. And then my 100,000s place, I have 1 minus 1, which is nothing. So my answer is going to be 34,481. And if I'm looking to see if my answer is reasonable, I could estimate. I could say that 155,000 is close to 160,000, and 121,000 is close to 120,000, and 160 minus 120. So if I did 160 minus 120, it's around 40-ish thousand, and 34,481 is really close to that. So I know that it is in fact reasonable. Okay, so this is a choice that's going to complete the statement. So I'm going to be picking one of these. I'm going to be picking one of these answers, sort of like an equation, which we're going to get into later. So the first side is 10,000 less than 24,579. So let's find out how much that is. 10,000 less, that means I'm just going to take 10,000 from here. So that means it's going to be 14,576. So that's good. Let's just do the other side now. 1,000 less than 14,576. So now I'm just going to take from the thousands place, right? I'm not taking from the 10,000s, from the thousands. So 1,000 from that is going to be 13,576. Now I'm looking to see, are they equal to? No, they're not equal, right? Because they'd be the same number if they were equal to. So is this number greater than this number or less than this number? So let's compare. In my 10,000s place, I have 1,000. Same. In my 1,000s place, I have a 4 and a 3. Well, the 4 is definitely bigger. So this number is going to be greater than this number. All right, in this last one, they want me to match the number or the value of its 5. So if I'm looking at this 5, it's in my thousands place. So it's going to be 5,000. So I've got to find 5,000. Perfect. In this one, the 5 is in my 10,000s place. So that means it's going to be 50,000. So I'm going to put it over there. This 5 is in my hundreds place. So it's going to be 500. So I'm going to 5 my 500. This 5 is in my tens place. So it's going to be 50. During September-October, a total of 825,150 visitors went to Grand Canyon National Park. If 448,925 visitors went to the park in September, how many visitors went to the park in October? Show your work. Well, it's telling me that I have a combined during September and October, I have this amount. And I know that September's is this amount. So if I subtract September's from my total amount of September and October, I should get October's. So I'm going to take the 825 and I'm going to subtract them. So 0 from 5 you can't do. So I'm going to have to borrow to the next door. I'm going to get 5. 4 from 2 is 2. On this one, I can't do 1 from 10, so I'm going to borrow next door. 10 from 9 is 1. I can't do 4 from 8, so I'm going to borrow next door. Then I get 6, and then I can't do this one, so I'm going to have to borrow for next door. 1 from 4 is 7, and 7 from 4 is 3. So in this problem, I can't read it all because I'm running out of time, but we're basically putting the numbers in order from least to greatest. And you use place value to do that. Okay, he made a number with 5 in the ones place, 6 in the tens, 4 in the hundreds place. What is the number? There it is. All right, good luck on your test. Study hard. I know you're going to do great.